Hi, welcome to Lesson 1 on Intro to Statistics. We're going to start our lesson on statistics by talking about averages and what an average means. So what I've done is I've pulled a few different real-life examples, and I tried to pull from a variety of different real-life situations just so that different students can feel like they have different interests in different things. So our first example comes from a sports example. So I don't really watch football, but I just Googled the average base salary of a wide receiver for the Eagles in 2019. And so I took a picture of what I found. So here's the source right there. And what I saw here was there's about 10 wide receivers for the Eagles in 2019, and this was their base salary. So what I would like you to do now is I would like you to find the average base salary of a wide receiver. So pause your video and go ahead and do that now. Okay, so if you're like most people, when you're asked to find an average, the first thing that you think of is the mean. So that's what I did. So to find the mean, you're going to add up all of these 10 data values, and then you're going to divide by the number of points in your data set, which in this case is 10. So I added up. Now, I did this a little differently. You can add up the exact numbers that you see here. Like you can add up 495,000 plus 495,000, etc. Or what I did was I put the numbers into thousands. So I just ignored these three zeros on the end of every number so that I'm thinking that these numbers are in thousands. And that just makes my computation in a calculator a little bit more efficient. It makes it easier. It makes it less likely to make a mistake because I'm hitting less buttons, so I don't have to enter all those zeros. So you can do it either way. You can enter all those zeros and you should get the same answer as me. So if you did it the way I did it and you thought of these numbers in thousands, then the number that you'll get on your calculator is 2623.2. And then you have to remember that that number is in thousands. So really the mean salary is $2,623,000 and $200. So that's the mean of this data set. Now, if you were to think about in real life, if you were to be drafted onto the Eagles team as a wide receiver, do you think that you would make $2 million, almost $3 million? So if I were drafted, and assuming I'm probably not that good as a wide receiver, I don't think I would expect to make over $1 million. I actually only see 3 people on here that are making over $1 million, and the rest of the wide receivers are making less. Assuming that I'm of average skill, though, I would assume I would make, somewhere in the middle if I were drafted onto the Eagles team. So to me, this number, this $2.6 million number, it doesn't seem to be an appropriate average for these 10 data points because it doesn't seem to truly represent if I were to be drafted today on the Eagles team, is that how much money I should expect to make if I am truly of average skill for a wide receiver? So you may have heard of these 2 other averages. One is called the median and the other is called the mode. However, in everyday life, we don't tend to think about these as averages. I'm not sure why. It seems like in school, many of us learn about the mean, median, and mode, and it's a very common phrase that you hear, like, oh, what are we doing? We're finding the mean, median, and mode. But in real life, how is that really applicable to us? So in real life, when you hear the word average, like in a commercial or in a statistical study, it doesn't always mean the mean. It could mean the median, or it could mean the mode, or it could mean even a different average that we're not going to cover in our class. So it's important to understand what the three most common averages mean, the mean, median, mode, and what they represent and how to find them. But it's also important to understand how to use them in everyday life. So if I were to find the median for this data set, where we're talking about the base salary of a wide receiver on the Eagles team in 2019, I'm going to list the values in order, chronological order, so I put them in increasing order, and I'm going to find the number in the middle. Now in this case, the number in the middle it doesn't exist because there's an even number of data points here. So because we have 10 values, The number in the middle is going to be the number in between numbers 5 and 6. So the way we find the median when you have an even number of data points is we find the mean of those two numbers. Notice how I didn't say average of those two numbers because all of these are averages. Okay, so the word average is too vague, so we have to get rid of that and be more specific. So the median of this data set is the mean of these two numbers in the middle. So if you add these numbers and then divide by 2, then you'll find the median. Now in this case, we get the same number because they happen to be the same number. So the median is 645,000. Now, if I were to be drafted onto the Eagles team in 2019 as a wide receiver, it seems more likely to me if I'm of average skill that I will probably make close to $645,000. I'm probably not the worst player on the team, which seems to be making $495,000, but I'm nowhere near the best player, which is making almost $12 million. Right? So $645,000 sounds like a more appropriate measure for the center of the data compared to using the mean. And so that's an important concept. So really what I want you to take away from this lesson is to determine which measure of an average, the mean, median, or mode, is the most appropriate way to measure the center of a data set, any kind of data set. In this example, we're working with the base salary of wide receivers on the Eagles, but it doesn't have to be that. It can be any example. Now, in this case, the mode is 495,000. The mode is the most repeated number that you see in the data set. And sometimes there is not a most repeated number, so in which case the mode would not even exist. So the mode does not always exist. It depends on the data set. Now, in this case, in this real life example, the number 495,000 is actually repeated 3 times, which is more than any of the other numbers in this base salary. So that is the mode. The mode is 495,000. But that doesn't seem to be a very appropriate measure for the center of this data set because, as we said before, the worst players, whatever that means in this case, seem to be making $495,000. So if you are the worst wide receiver drafted onto the Eagles, then you might expect to make $495,000. But if you're of average skill, I believe that $645,000 sounds to be a more appropriate estimate, closer to what you would expect to make. So it's important to understand these 3 different calculations and how they're used, because if somebody wants to convince you, let's say you're a very good wide receiver, and in this case it probably doesn't make sense because I don't know how the NFL drafts people, but let's say you had a choice between 2 teams that really wanted you, and one team said, well, our average salary is $2.6 million, and another team said, our average salary is $645,000. You might think like, wow, those salaries sound really different. I'll just go with this team that sounds like the average is high, and then you actually get drafted, and really you only make $700,000, and you're like, wait a second, I thought that the average was $2 million. What happened? So it's important to understand that if companies or advertisements that you see are trying to convince you to do something or to buy something, they could be using a biased average to convince you to do something. So I'm going to show you some real life examples of that in a minute. But that's why it's important to understand this in real life. So I don't want you to just be doing meaningless calculations. I want you to think about which average, the mean, median, or mode, would be the most appropriate. So let's look at this housing price example. So I took a picture of this on Zillow. You might recognize this area. So this is actually right outside of Stockton. And at the time, in 2019, I was looking to purchase a house near Stockton because I wanted to move closer. So this is from my real life. You'll notice that most of these houses are in between like 150,000 to maybe 300,000, right? So most of them are in between those 2 numbers there. But there is one that's much higher than the rest. So we call numbers like this 995,000, like this house is almost $1 million. We call numbers like these outliers. So this number is much, much higher than the rest of these data points. The same way that in our first example, these 2 wide receivers, whoever they are making way more money than these other wide receivers. And because of these 2 outliers, because they are much farther from the rest of the data set, those 2 outliers skew the mean. So they bring the mean much higher than the true average, where the real center of the data is. I want you to pause your video now for 15 seconds and think about why. Why do outliers bias the mean, but they don't bias the median? So they're not going to move the median. So why is that? Pause your video now and think about that. So the reason why outliers bias the mean are because of the way the mean is calculated. So the mean is calculated by adding up all of the numbers, in your data set, and then dividing by however many there are. So if you have numbers that are way bigger than the rest of your values here, of course that's going to bring the sum higher than the rest of the data points. So if you have outliers that are higher, the mean is going to be higher than the true average, than where the true center lies. If you have an outlier that's lower, we don't have that in this case, but if you have an outlier that's much lower, then the mean will be lower than the true average, than where the real center of the data falls. The median, however, is not biased because the median always represents the number in the middle. It's the number smack in the middle. It's based on location. So what happens on the outside, what happens over here or over here, is not going to affect what happens in the middle of the data set. Right? So that's important to know, because when there are outliers, the mean is not a good estimate, surprisingly. Surprising to me, because I just always assume that everybody uses the mean, but it's not true. If you're dealing with an honest company, a company that's trying to give you an appropriate measure for their average, if there are outliers, then the median would be the best measure. Okay, so we're going to come back here and look at this housing price example where there is an outlier. So, considering that this has an outlier, which average would be the most appropriate way to tell me the average price of houses in this area? Would it be the mean, the median, or the mode? If you're thinking it should be the median, you're exactly correct. So if you want to find the mean, though, I did it for you. I took the house prices that I could see, because some of them are, kind of covered up. But I took all of them that I could see, I added them all up, and then I divided by the number of houses that I had there, which was 13. And so I got 259,000 for the mean, which isn't too bad, but it's higher than it should be because this outlier here is biasing the average. It's bringing it too far up. The median is 220,000. And again, I put the numbers in order, and here there are 13 total numbers, so that's an odd number, which means the median should be a number that you can see. It's right in the middle. Unlike our first example, the median didn't exist. It's right here in the middle, which there is no middle number right there because there's an even amount of data points in this set. Okay, so when there's an odd amount of data points, the median's right in the middle. The mode is 220,000 and 225,000 because if you scan through this picture, 220 is repeated twice and 225 is also repeated twice, and that's the most frequent repeated numbers. So there's actually two modes in this case. So it doesn't seem appropriate to use the mode, though. If it's just the most repeated number, why would you use the mode to represent the center of the data? The median seems to be the most appropriate in this case, again, because there is this outlier. If this outlier did not exist, then the mean would be the most appropriate way to measure the average. So you're probably sitting there wondering, like, when would I use the mode then? That's a great question. So you would use the mode when you're dealing with data that are not numbers, so not numerical data. So for instance, if I asked all of us to list our favorite color, so everybody in the class would write down their favorite color, and then you would show me what it is. So mine is blue. So let's just assume that, everybody held up blue, and we've got a few reds and some yellows and greens. So if we all have blue, then I could say that the average favorite color of people in our class is blue. And the way I'm finding that average is by using the mode. The most repeated word that I see is blue. There's no way for me to find a mean or a median if we're dealing with words. Like, I can't add up blue plus green. What am I adding? Those aren't numbers. So the mode is the most appropriate way to measure what's called qualitative data, which we're going to talk about in a few minutes. So just keep that in the back of your mind if you're thinking, when is it most appropriate to use each of these three things? That's a great question. That's the focus of our lesson. Here's another example. So I took this from like a nursing/health science example. So this is a distribution of healthy human oral body temperatures. So for instance, if I were a participant in this study, my average body temperature is like 98.2 degrees, and my husband's body temperature is like 76 degrees. So that's actually a big difference. A 1 degree difference is, in your body, that's a big difference. If I'm 98 degrees and my body temperature increases 2 degrees higher, and now I'm at 100 degrees, now I have a fever. So it's a big difference when you're talking about your body temperature. So I would fall somewhere close to this 98.2. I would fall somewhere in here, whereas my husband would fall in this lower end. Like he's much lower. So this is called a histogram. So this is telling you two people have an average body temperature of 97.6, and 6 people have an average body temperature of 97.8. And 22 people are fallen here, 30 fallen here. So you can see, like, there's a lot of people that were, asked this question, that were participating in this study. If you want to know the exact amount of people, you would add up these numbers: 2 plus 6 plus 22 plus 30 plus 83 plus 68. So it looks like there's like somewhere between 200 and 300 people in this study. Maybe more. Maybe between 300, because I'm just guesstimating here. It looks like 100 there plus another 100. Yeah, so maybe a little more than 300 people in this study. So if you just think about this histogram, what do you think, which average, the mean, median, or mode, would be the most appropriate way to measure the average human oral body temperature of someone that's healthy? Now, if I have a histogram, I'm not going to want to find the mean because it's a lot of calculation. So I'd have to add up 97.6 plus 97.6, because there's 2 of them, plus 97.8 plus 97.8 plus 97.8 plus 97.8 plus 97.8 plus 97.8, because there's 6 of them, plus 98 22 times, right? And you can get a little bit more efficient. If you're saying, like, well, if I'm going to add 97.8 6 times, I'll just multiply 6 times 97.8. And then I'll add that to 22 times 98, plus 30 times 98.3. And that's fine. That still seems time consuming. So if it were me, I wouldn't find the mean. I would just go right to the median. It doesn't look like there's any outliers in this data set. I'm looking at the ends of the distribution. And I know that there's no outliers because I don't see a bar that's like farther away from the rest of the bars, right? I don't see, like, there's no bar out here and there's no bar way out here. So it looks like there's not outliers. And this data set looks pretty symmetrical. Like, it looks like a nice bell curve that has some symmetry to it, right? It doesn't look off-centered. It looks pretty much like a nice, perfect hill. So when you have a symmetrical data set like that, the mean is going to be very close to the median anyway. So I would either use the median, or even in this case, the mode, because the mode is the most repeated number. And I can see the most repeated number is right here because there's 83 people have this body temperature. And because this looks like it's the center, the mode is going to be very close to the median and very close to the mean when you have a symmetrical data set like this. So if it were me, I would do this very quickly, and I would say the average body temperature looks to be about 98.5, and if you ask me what measure I'm using the mode, the most repeated number. You could still use the median, but again, you'd have to figure out how many people are in this data set, and then you'd have to find the middle, right? So if there's 300 people, the middle is around 150. So then you'd have to figure out where exactly is the 150th person by adding up these numbers. So, it's a lot. I would just use the mode if you have a symmetrical data set there. Okay. Oh, look, I even found out how many people are included in this data set. So again, you can just add up those numbers that you see, and it looks like there's 308 people. And there's no outliers, again, because we didn't see any bars that were far away from the majority of the bars. So the takeaway lesson here is that the average is not always the mean. The average can be the mean, the median, or the mode, or it can even be something different, but those are the most common measurements. Knowing which average is most appropriate to use to approximate the center of the data set is critical to interpreting data, especially real-life data. And histograms are not always symmetrical. They can be skewed one way or the other, but when they are symmetrical, like this one, the mean, median, and mode are all very close when you actually calculate them. So you can use whichever one is easiest to find. I'm going to show you some real life examples right now. So I'm just going to make my screen a little bit bigger. So I received these in the mail. So if you're looking, I'm just going to show you one at a time. So here's one letter that I received. And here's another letter that I received. So if you're looking at these, you probably guess what these are. One is from State Farm, one is from Geico. These are quotes for car insurance. So they are sending me quotes to try and get me to switch to them. I have Progressive for my car insurance. So if you look, both of them say you will save an average of $536. And then over here, Geico says you will save an average of $500. They both use the word average. What do they mean by that average? Are they using the mean? Are they using the median? Are they using the mode? And which average would be most appropriate? So if you were doing this and trying to be honest to your possible future customers, which average would be the most appropriate way to measure the average amount I could save if I switched to you? If you're thinking the median, you're right. The median would be the most appropriate because somebody could be paying a lot of money for car insurance, and then when they switch, they're saving like thousands of dollars because they're overpaying dramatically for car insurance. So that outlier is going to bias it, making it seem like we could save more money if we switch to them. Really, if I called State Farm right now, I might not even save any money. I might pay more money by switching from Progressive to State Farm. Now, I looked on, so if you look at State Farm, they have this little 1 up here, right? So it's like a little reference note. It's like a footnote to go look. So I'm going to read down here. Here's their footnote. It says, average annual per household savings based on a 2019 national survey by State Farm, who reported savings by switching to State Farm. It still doesn't say anything about whether they use the mean, median, or mode. Now, if you look at other companies, they will be more straightforward, and they will say, like if you go on to Zillow and you look at the average house prices, Zillow says directly, we use the median to calculate the average, which makes sense. You should use the median because there could be outliers in the housing market. So again, this is important to not be deceived into buying something or taking something like a medicine or something when someone says like, oh, well, you know, the average is this, and so you should come use our product, buy our product. You should be skeptical of what they mean if they use the word average and don't say exactly what average they're using. And it's usually only the mean or the median. So they should say which one. And more often than not, the median is the more appropriate estimate because of outliers. Okay, so the last thing that we're going to do is there's some practice problems there that you can look through. So go ahead and feel free to look through those practice problems and do them. I'll post the answers for you. But the last thing I want to talk about is the difference between quantitative and qualitative. So I said we would talk about that a little bit. So in statistics, there are two kinds of variables. There are quantitative variables, which can be measured by a number. They have a numerical value. And then there are qualitative variables, which are measured by words. When you have a quantitative variable, you can have a discrete variable or a continuous variable. Discrete variable means you can't break the number down into smaller pieces. So like if I'm measuring people, I can't have half a person. If I'm measuring chairs, couches, I don't have half a couch, right? So those would be examples of discrete variables. Continuous variables are things where if I get a more accurate tool to measure that, I can always give you a more accurate measurement. So like my height, I'm 5'5". But if I get a really precise ruler, I can tell you that I'm 65.18752 inches, right? And I can keep going with that decimal. So that's called a continuous variable because I can always get more precise. And when you're measuring something like height can be anything. It can have, decimal points, fractions. It can have all kinds of numbers there. So that would be a continuous variable because it's measured on a continuous interval. It's not like discrete values on a number line, right? It can be all the numbers in between, 0 and 100 or something like that. Again, qualitative just means words, right? So like our favorite color, that would be a qualitative variable. So there's some practice down here where I want you to go ahead and I'll just do the first one with you. The length of time students spend studying for an algebra exam, because you're measuring time there, time can always be measured at a more finer grained size. So like, did you spend an hour studying, or did you spend an hour and 10 minutes, or an hour and 10 minutes and 2 seconds, or an hour, 10 minutes, 2 seconds, and 5 milliseconds, you can always get smaller. So that's a quantitative continuous variable. It's quantitative because it's a number. The way you tell me how much time you spent studying, you have to tell me a number. And it's continuous because you can have fractions and decimal units for the amount of time you spent studying. Okay, so that's it for this lesson. Please contact me if you have any questions.